This is 1A. It says a tank has a height of 10 feet. So the height of the tank is 10 feet. So I'd probably be kind of thinking, okay, I got a tank of some sort. So I want to go slow and comprehend as I read. The height of the tank is 10 feet. The area of the horizontal cross-section. Horizontal. Cross-section means slice. So I have a slice, or I have a slice here, and the area of the slice, something like that, the area of the slice at some height h is given by the function a. So a is the area of a slice. A is continuous, and A decreases as the height increases. So my drawing was kind of wrong, so I did a new one down here. As the height of the tank goes up, the cross-sectional area of a slice goes down. So I have no idea what the tank actually looks like, but perhaps something like that. Whereas you go higher in the tank, the area of the cross-section gets smaller and smaller. Something like that maybe. So the area is very small there. The area is very large down here. Use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. So 3 subintervals following the table. So the biggest thing I have to remember is I always calculate the volume of an object by paying attention to the area of a cross-section. So I pay attention to the fact that the very bottom slice of the tank has an area of 50.3. So when the height of the tank, so the very bottom of the tank, the area of the cross-section is 50.3. If I simply multiply that value by a thickness, I get the volume of that cross-section. I do that repeatedly. That's how I can find the volume of any solid. So every volume problem on the AP test is based on finding the area of a cross-section first, then multiplying by the thickness of the cross-section in order to get the volume of one cross-section. You do that for many different heights, and for all the different cross-sections, then you get the entire volume. So we're supposed to do a left Riemann sum, which means we are basically approximating that for the first 2 feet of the tank, the first 2 feet here, the area of every cross-section will be 50.3 because we're doing a left Riemann sum. So we're basically making this assumption, which is not true, but we're just trying to do an approximation. And we're going to find the volume of that cylindrical disc down here. The volume of that disc is 50.3 multiplied by a height of 2. That's right here. It's because we're doing a left Riemann sum, so we're picking the value of A on the left. We then go to the next slice, which we assume is this one, where we assume the area of the slice is not 50.3 anymore, sorry, 6.5. Oh, wait a minute. I need to fix my drawing. This shouldn't be 50.3. This is supposed to be 14.4. So we're assuming the area of this cross-section here is 14.4. And then the thickness of the cross-section, we're assuming that is 3 feet. So that's this computation here. That finds the volume of that blue cylindrical disc. Then we go to the next one. That's our next value here. So it's the 14.4 times the thickness, which is 3. Then we go to the last cylindrical portion, where we say the area is 6.5. The thickness or height is 5. We find that volume. Add those together, that gives us our approximation for the volume of the object. The object volume is much more complex, but we're just doing a Riemann sum approximation of it, and it's a left Riemann sum. Okay, You don't have to do the computations, so you really get 2 points if you have your Riemann sum written out correctly. You don't have to come up with this decimal value. They did ask for units. It says right here, indicate units of measure. So you get another point if you did that. 3 total points on part A.